What would life be like without a word problem? And this is kind of an interesting word problem. Interesting from the standpoint that I got to do a little bit of thinking about this thing to determine what's going on. It says, let me read what we have. It says the swing arms of a ride are 72 feet long. The height of the axis from which the arms swing is 88 feet, and the angle of rotation from the standard position is negative 195 degrees. What is the total height of the ride at the peak of its swing? Wow. Okay, you might say, what in the world? Well, let's see. Let's imagine, if we will, that we got some kind of tower here. Crude drawing. And it's got a swing arm that we're told is 72 feet long. And that means that this portion here is also 72 feet long, same swing arm. And that from the axis to the ground, so from here to here, is 88 feet. And that angle of rotation is negative 195. And we want to find the total height. So what we want to find is not just this 88 feet, but we also need to find that height right there. Okay. Well, and we're going to use trigonometric functions to do that. So, now, we've defined the sine function as the opposite over the hypotenuse, so remember SOHCAHTOA, and we have also defined it as on the coordinate plane as the y-coordinate in the unit circle over the radius. Now, so the swing arm is serving as our radius. If we were to take this and go all the way around in a circle, that would be our radius. That's 72 feet, right? And also, if I'm trying to find this height right here, and if that formed a right angle, then 72 feet is the hypotenuse. Now, I need to find my reference angle. And my reference angle is the distance from the terminal side of the angle to the closest x-axis, which would be right there. Now, there's a couple of ways I could do that. One, I could just be thinking, I could think my way through it. If this is 180.95, when it passes 180 right there, and it's got to go 15 degrees more, so it is, and I should put the sine of theta here, sine of theta, maybe to be totally accurate. That certainly would be one way, if I'm just visualizing that if I go 195 degrees, and come back to the x-axis there, it's got to be 15. Or I could take 180, let's say, times the positive less the positive coterminal angle. Well, the positive coterminal angle would be 360 minus 195, which is going to equal 165. And then to get the reference angle, 180 minus that positive coterminal, which is going to be 15. Or I can just think, hey, I passed the 180 mark, went 15 degrees above it, it's 15 degrees reference angle. All right, so I then can substitute we can then say that the sine of 15 degrees equals y, which is what I need to know, over the radius, which is 72, and then to solve for y, which is just going to give me this portion right here. What's my total height, though? It's this portion plus that 88 feet. But let's go back. Let's find just this portion right here from the axis up to the top. And so that would be 72 times the sine of 15 equals y. All right, now, when I'm using my calculator, here's a reminder. I want to make sure what mode I'm in, because on the fourth line down, I've got radian and degree, and we're dealing in degrees here, not radians. So I want to make sure I'm in degree mode, which I am. And so I'm going to quit out of there, and then I'm going to go 72 times the sine of 15, that reference angle. And that equals 18 point, I'm going to round it to the nearest tenth. That equals 18.6. Now, is that my height? No, because I got 88 feet from the ground. So my total height then is 88 plus this portion right here, which we have said is 18.6. So 88 plus 18.6 would give me the total height of that ride at the peak of the swing. And so what's that going to be? 106.6 feet. Now, if you don't enjoy problems like that, I would say something's wrong with you, but that's not really true. But when you think about it, and think of all the thought process I had to go through, and we had to go through to get to this, and it does make it kind of interesting. 106 feet off the ground. Also, at the lowest point, I'm only 16 feet off the ground. How about that? Didn't ask me that question, and I'm sure you don't care. But I don't care if you don't care. Doesn't bother me.